Dear students, today we are going to see about WSS process and problems based on that. In the class, we have discussed about WSS process. What is a WSS process? First, we need to know stationary. What is stationary? A process whose mean is constant is a stationary process. So, for example, we will have a problem here. If x of t equal to a cos t plus psi, where psi is uniform random variable in the interval minus pi by 2 to pi by 2. The question is about checking the process is stationary or not. So here psi is our variable. So psi, PDF of psi is 1 by b minus a. So that will be 1 by pi by 2 minus of minus pi by 2 will be plus pi by 2. So 1 by pi in this interval. So e of x of t will be minus pi by 2 to plus pi by 2 because the interval given is like that. So in general, what is the formula? E of x of t. X of t into f of psi into d psi. So actually here instead of dy, it should be d psi. It is mistakenly maybe written dy. So x of t is a cos t plus psi and f of psi is 1 by pi into d psi. So if we integrate it, we will be getting 2 by pi cos t. So the question is, it is stationary or not? So if a mean is constant, then only it is stationary. So here mean is dependent on t, so it is not stationary. So that is the conclusion of this problem. So it is a first stage thing. So to prove a process is not stationary, that is the case here. But if we want to prove a function is WSS, you need to go one more step ahead. First to prove E of x of t is constant, and then Rxx of tau. Autocorrelation function depends only on the time difference. That is actually time difference, we will take it as tau. So this problem actually we have seen it in the class. So we have discrete case here and we proved E of x of t. The question is to prove not stationary. So we have considered here as n into p of n. So that we have actually discussed this in detail in the class. So I just leave this. Now WSS. So this problem, even though we have considered in the class, I will just tell you once again. So this problem, a is the random variable and cos lambda t is lambda is a constant here actually. That is not mentioned here anyway. Lambda is a constant. So e of x of t coming as 0. So it is a stationary process, we may say in the first step, but we need, the question is WSS. So to prove WSS, Rx of t comma t plus tau. The time difference will be t plus tau minus t. So that will be depends on tau only. So a cos lambda t into a cos lambda into t plus tau. So if you are integrating it, you will be getting this thing. But the value depends on t also. So it is not a WSS process. So in the second case, you need to prove it is a WSS process. So same way that this question also we have discussed in the class. So E of x of t is 0, a constant, and also Rxx of tau is a k cos lambda tau. So that is depends only on tau. So this is a WSS process. Same way here you can see it. So here they are asking one more term, triple SS process, triple SS, strict and stationary. So we are finding E of x square of t. So that is coming as cos square t plus sin square t, that is 2. But strict and stationary means it is second order stationary here, but third order we need to check whether, because strict sense means in all orders it should be stationary. So in cubic order it will be this thing. So it is depends on t. So it is not a strict sense stationary process. So with this I will conclude today's lecture. Just ask me doubts in this regard in future. Let us see. Contact me if any doubts arises in this. Thank you, students.